everybody, and today I'm going to be talking to you about our next learning target, which is all about the percent composition of a compound. Now what percent composition refers to, and you'll also see it referred to as percent by mass of an element, it's basically how much of a compound each element is. Okay, so for example, if we're looking at NaOH, we're looking at what percent of the compound is sodium, what percent of the compound is oxygen, and what percent of the compound is hydrogen. Okay, so there's two different ways that we're going to be looking at figuring this out. One method involves, or the first method involves if we have no experimental data. So if you're given a chemical formula for a compound, say NaOH, and you want to know what the percent composition of each of the elements is, you're going to use the molar mass to calculate that. Okay? Now, once you have the molar mass, which we know how to figure that out, we've already learned this, we're going to use this equation right here to actually calculate. Now, the percent mass of each element is equal to the molar mass of the element divided by the molar mass of the compound times 100. All right, so let's look at this. Let's say, you know this using tests. Let's say you get a test back and you got 75 questions right, and there were 100 questions, okay? If you take 75, the percent right, divided by the total questions, and multiply that by 100, you get your percent on the test, right? Same idea here. We're taking the part divided by the whole and multiplying it by 100 to get our percent. Part divided by the whole. Part, molar mass of the element, divided by the whole, molar mass of the compound, times 100. We'll do this for each element that's in the compound. So sometimes, in the case of NaOH, we would have to do it 3 times. Sometimes you might have to do it more. All right, so now our second problem-solving method, before I actually get into showing you how to do these, is if we are given experimental data. Now, by experimental data, I mean measurements. We're given some kind of mass measurement. Then use it, all right? If you're given the data, use the data. Now, oftentimes, this method will involve 2 steps. The first step being that you're going to have to write a simple equation for what's going on in the reaction. Now, it doesn't mean you have to write a full balanced chemical equation like we've been doing, but you are going to want to write a simple equation so that you can see visually what's going on. Now, the second step is very similar to this equation. All right, the only difference in the equation down here for our method 2 is that instead of using the molar mass, we're using the experimental mass of the element divided by the experimental mass of the compound and multiplying by 100 still to get it into a percent. So the only difference between this equation and this equation, this method and this method really, is we're using molar mass if we're not given any data. If we are given data, we're using the data, okay? So let's see what this looks like. This whole board is going to be all about the first problem-solving step. So problem-solving method number 1. So this case, we are given a chemical formula, but no experimental data, right? So no mass measurements. All right, what do? We're going to use the molar mass. So find the percent composition of hematite, which is Fe2O3, okay? In order to do this, we need to first figure out the molar mass of Fe2O3, which I've done here for you because you already know how to do this, so I didn't want to walk us through it. We have 2 irons. Each iron has a molar mass of 55.85 grams per mole. We get 111.70 grams per mole, all right? Total for the compound, between the 2 irons and the 3 oxygens, we have a molar mass of 159.70 grams per mole. Great. This is all the information that we need now. We're ready to actually do our calculation. So remember, this is part over the whole. So if we're looking at just iron, we need to start with just the mass of the iron in the compound, not just one iron, because this is Fe2O3. We're looking at both irons for a total molar mass of iron of 111.70. Okay, 111.70 grams per mole. Don't forget that molar mass unit. Now, part over the whole. What's the mass of the whole compound? We already figured that out. 159.70 grams per mole. All right? We also need to make sure that we're multiplying by 100. That's the only way we get it into a percent. Okay? Now, notice that we have grams per mole on top and bottom, so that unit crosses off. That 100% will give us a unit as a percentage, okay? So, when we actually calculate this out, we get 69.944%, right? This is the percent of iron in Fe2O3, okay? There's iron. We also have to figure this out for oxygen. Oh, let me also reference the sig figs. We have 5 sig figs on top, 5 sig figs on bottom. Your answer should have 5 sig figs. That's why it's such a long number. Now for oxygen, we're looking at the part of just the oxygen in the compound divided by the whole, okay? So this time we have 48 grams per mole, because that's what I figured out is the molar mass of oxygen in that whole compound. We're going to divide it by the whole. Notice that the whole is the same whole that we use for iron, right? The compound molar mass does not change. 159.70 grams per mole times by 100, only way to get it into a percent. And what unit crosses off here? Grams per mole, right? So we multiply or divide this out and multiply, and we get the percent of oxygen is 30.06%. Now, notice, I only have 4 sig figs on top, 5 on the bottom. 4 is less than 5, so my answer can only have 4 sig figs there, okay? Now, think about percentages, right? If we're looking at parts of the whole, right? Iron and oxygen are the only things that make up Fe2O3, okay? So together, those two percentages should equal what number? They should equal 100%. And if you add them together with correct sig figs, or correct decimal places, right? Only 2 decimal places, we get 100%. Perfect. That's a good way to check our work. Now I'm going to take it one step further. This is still the same problem-solving method, but now that we know how much of this compound is iron, can we figure out what mass of iron is in a 200-gram sample of Fe2O3, right? We're dealing with the same calculations we've done up here. We're going to use all of this, but now we also know that we have a 200-gram sample, okay? Great. Well, we already know that the percent of iron here is 69.944%. I don't want this in a percent, right? I want it in a decimal. So I'm going to divide it by 100. All that's going to do is give me a decimal for this number, okay? Now, I know that the 69.944% of the compound is iron, and I know that that iron, the whole sample, has a mass of 200 grams. So, 69% of 200 grams, I'm going to multiply it, is going to give me a mass of 139.8 grams. So of this 200-gram sample, 139.8 grams of it is iron. Now, tricky thing here, not tricky, but we have to put this in sig figs also. My only measurement that I'm given, 200 grams, has how many sig figs? 3 sig figs. So that means my answer has to have 3 sig figs. So I get 140 decimal grams is iron. Or you can just put 140 decimal grams iron, okay? That decimal has to be there or else you're only showing 2 sig figs. Now, let's take a look at the second problem-solving method. This is what we're going to use if we have data. So this would be if the problem gives us measurements for mass, right? Not just one measurement for the compound, but we need to know some other measurement. Here's an example. When a 30.98 gram sample of phosphorus reacts with oxygen, a 71 gram sample of phosphorus, I meant to put phosphorus oxide, is formed. What is the percent by mass of P and O? Right, now I said, step 1, we have to write an equation, a simple equation, not a fully balanced chemical equation with state symbols. Right, we just need to know what's going on here. Here, we have phosphorus and oxygen reacting to form a compound, right? That's the basics of what we got going on. What do we have? Well, we know that we have 30.98 grams of phosphorus. 30.98 grams. It says it reacts with oxygen. Does it say how much oxygen? No. So we don't know how much oxygen here. We do know that it forms a compound with a mass of 71 grams, 71.00 grams. All right, we know how to figure out the mass of oxygen because remember, according to the law of conservation of mass, mass cannot be created or destroyed in a chemical reaction. That means we can do simple subtraction to figure out the mass of oxygen. 71 grams minus 30.98 grams of our phosphorus should give us the grams of oxygen. And we get 40.02 grams of oxygen. Great. We know that we have 40.02 grams. All right. Now, we're on to step 2. Step 2 is the same as how we did our other problem, right? Percent mass of an element is equal to the part over the whole. The difference is this time we're using the experimental mass because we have the experimental masses. We have data, so let's use it. All right, so step 2, we're going to start with phosphorus here. How much phosphorus do we have? 30.98 grams. So I'm going to have 30.98 grams. All right, this is the part of phosphorus. What's the whole? The whole is going to be the whole compound. All right, so over 71.00 grams, multiply that by 100. Now what unit crosses off? What unit crosses off here? Notice that it's not grams per mole this time because we're not using the molar mass, we're using an actual mass measurement. So it's grams that crosses off. When we calculate this out, we get, oops, I want it red, 43.63% phosphorus. Great. Phosphorus is done. Now we just need to do oxygen, okay? Now, oxygen, we know, we already figured out, has a mass of 40.02 grams. So we have 40.02 grams. That's our part divided by the whole. Remember, the whole is the same for both the elements that we're using. It's going to be the mass of the compound. 71.00 grams times 100. What unit crosses off? My grams. All right, and when I calculate that, what percent do I get? I get 56.37% oxygen. All right, now double check our answer. When you add 43.63 plus 56.37, do you get 100%? You get exactly 100%, right? So that is how you kind of know, and you can check your work to make sure you're on the right track. That's it for percent composition. See you for the next video.